Okay, so Chris, Ananya, I believe your camera has got some problem, right, Ananya? Yeah. Okay, Chris, how about yours? You can keep it on. Okay, yeah. So, what did you do in the last class? Does anybody remember it? I'm sorry, sir? That is something that we have been doing for our last two classes now. But there was something specific about the last class.
The one where I don't know how to say it, but manipulate limits,
Right.
and subtraction.
Exactly. So those are called algebraic properties. Like I mentioned in the last class that when we, no matter how old we grow, we will keep on doing only four things in life when it comes to math: addition, subtraction, multiplication, division. So even with the limits, and those four operations are called algebraic operations, and those are governed by certain rules, which are called properties. Yeah, algebraic properties. So same thing applies for limits also. When we talk about having one limit known to us and one function with a limit known to us, another function with a limit known to us, we can as well add those functions for the given limit, and that becomes a compound function for us. Likewise, we can subtract, we can multiply, we can divide. Okay, and the same basic rule of algebraic operations apply in the case of compound limits also. Yeah, that's precisely what we covered. Chris, did you get a chance to look at the video of the last class? Yeah, so you're on the same page. I'm just trying to confirm that. It has nothing to do with I getting one extra view. It's more about making sure that we are on the same page. So before I move on, just a quick announcement, okay? So what I started insisting everybody to do with respect to the video, right? Because I don't have a lot of subscribers. Only my kids have subscribers, right? And it has nothing to do with subscribers or views as far as the videos go. But I'm trying to make sure that these videos are actually used for the right reason by all my kids. So, right from first grader all the way till you guys, okay? What I'm requesting everybody is, make sure that after the class, within 24 hours, within 48 hours, the video of the previous class is watched. And you guys, when you watch it, your whole purpose is to compile your own notes. Say, okay, this is what we learned. Okay? And once you do that, put a comment on the video itself. Say, okay, sir, this is Vedansi. And in this class we learned X, Y, Z. Just one line, nothing more. Okay? Same thing for Chris also. Same thing Nanya also will do. So what it will ensure, because since I have started tracking these things, just to ensure the effectiveness of the whole exercise that we do, these videos are made for a reason, right? So I'm tracking it, and I'm going to reward the kids also, right? So every quarter I'm going to pick up 10 kids across all groups, and I'm keeping a budget of $300 aside. That 300 will be distributed among all the kids. It will be a small token of gift from my side. It has nothing to do with a gift or a prize, but more like a motivation. Okay, so to make sure that everybody stays disciplined, joins the class regularly, participates in the class to get maximum benefit from it. If they have any doubt, they should ask the questions to make it as engaging as possible. And then after the class, watch the video to make sure that you are reaffirming what you learned in the class. And then for you guys it's not applicable, but for everybody else, they have to submit the assignment also. So that also gets graded and rated to make it a complete package of learning journey, right? Otherwise, me coming to the class and doing preaching for 1 hour and then everybody forgetting me doesn't actually become valuable for anybody. Okay? So that was just a context setting. So I'm certainly looking forward to hear more. At least get into the feedback mode. What the video, put a small comment saying, okay, so this is Chris. Watch the video and we learned this thing in the class. Okay? So that gives me assurance that okay, it's using the video for the right reason. That's it. Alright. Now coming to what we want to learn today. with a little bit of different enhanced flavor to it. Right? So in the last class we talked about algebraic properties of the compound limits. Yeah. Now in this class we are going to focus on deriving. So let me read the topic that I have captured so that I don't misguide you guys. We are going to focus on determining limits using algebraic properties, applying the direct method of substitution, and we will record that what it means. Similarly, we will try to figure out how do you determine limits using algebraic manipulation also. We saw part of flavor of it. And then we will talk about limit of piecewise functions, and we will see what it means. How do we decode a function into a breakdown, and then how do we define the limits? Okay, so that is the primary objective. But then in today's, if any of you got a chance to look at what are the questions that I have put for practice today, you will see a wide range of questions that we'll deal with, which will include limits. It will include finding limits for trigonometric functions. It will have questions related to how do you find limits of even algebraic or log functions. Okay, so let's see what are the things that we have in our plate and how we are going to tackle them. Everybody can see the screen, okay? Grace, Ananya, Vidansi, everybody? Okay. So we are trying to find out limits using direct substitution. What does it actually mean? Let's say I have a function. I have a function f of x equals x squared minus 2x plus 7. Yeah. So I have a function f of x equals to x squared plus minus 2x plus 7, and we are trying to find out limit of f of x when x is approaching minus 4. And you have no other information right now. Okay? We just have to find out limit of f of x when x is approaching minus 4, and this is the definition of the function. What is the first thing that comes to your mind? How do you go about it? And yes, that's it. Okay, that's one point of view. Chris, what do you think?
I'm not sure.
Okay, Nanya?
I don't know either.
I'm sorry, Vito?
I don't know either.
Okay. So, one request to everybody would be whether you know things or not, still, see, our brains are so many equipped that even for the most difficult problem in life, your brain will think something, okay? Something. Whatever comes to your mind, don't hesitate to share that. I think that's what Vidansi did. I'm not sure if Vidansi knows this already or not, but what she said was that if I have a definition of function given to me, yeah, I have to find out the limit of the function for when actually approaching that value. I'll just substitute the value. Okay? And this is the actually the what do you call it? The concept behind here, which is called direct substitution. That's first thing that we are going to learn today. Whenever you have any function definition and you have to find out the limit for the function when x is approaching certain value, you can just substitute the value to find out the limit. This is called direct substitution. And again, it is not as simple and straightforward as it sounds, but for the sake of simplicity, what we will do is we will just try substituting this value here in this function and see what happens. Okay? So when we try to find out the limit of this, we will say, okay, wherever I have x, I will substitute that by minus 4. And 16, minus 4 square is 16, minus into minus plus 8, 16 plus 24, plus 7, 31. This is what we got by just substituting it. Yeah. Now the question is, if life was so very easy, why did we even get into the hassle of finding out limits and all that? Now let's take a step back and think about it. See, what does limit do for us? Limit just gives us the ability to determine what is happening here. Limit just gives us the ability to, if I am talking about any function, drawing this graph for us, limit is a concept that tells us whether the function is continuous at that given value of the input or not. If I am talking about, let's say this is 2, this is 4, this is 6, and let's say at 6 what happens is, functions comes like this. At 2 what happens is, so when you have a function defined like this, okay, a graph like this, if you are trying to find the limit at x equal to 2 versus limit at x equal to 6, there are two things that we are trying to find out. Let's say when we put it x equal to 2, we say that okay, everything was working fine, only when x equal to 2 it became discontinued. Okay? But limit exists. Similarly, at this point, the limit does not exist because it literally fell apart. Yeah? Moved away from each other. So limit just tells us limit of a function x when x is approaching any value, let's say 2 here. This is equal to f of x when x is equal to 2 if the function is continuous, and it will not be equal to this if the function becomes discontinued. So limit only tells us whether just tells us the behavior of the function at the given value of the input. That's it. But otherwise, in this case also when we are approaching 2 from this side and this side, what we say, okay, the limit exists because from both the sides it approaches the same value as f of x. That is how we define limits. So that is why when we talk about determining limits by direct substitution, we can just plug in the value of the x that it is approaching towards to get the value of the limit of the function at that point. Does it sound okay?
Yes.
So direct substitution just tells us, okay, find out the value of the function for the given value of the input, and that is the limit of the function when x is approaching that value. Now, is it that easy always? We'll see. So let's look at some more examples. Now, let me pick up, okay, f of x equal to x cube plus x squared divided by x squared minus 1. And somebody asks you to find out limit of x approaching 1. What will happen in this case? You will say same thing. Oh, I have to find out when x is approaching 1. I will plug in the value here. This became 1 plus 1 cube is 1, 1 square is 1, divided by 1 square is 1, minus 1. And became 2 divided by 0, undefined. Now we are not going to just find this. Why? Just substituting it. So that is where the flavor of factorizing it plays an important role here. And this whole function definition, which was like this, will get changed or we will call it a piecewise function definition. Let's look at it. Now here in this case, let's first look at simplifying it. Numerator has x cube, meaning x square is common. This becomes x plus 1. This divided by x square minus 1, which we can as well split into x minus 1 times x plus 1. And then later on you can say this becomes x square by, this became x square by x minus 1. Okay? So here, if you look at this function, what is happening is, you see that if I put, let's say, if I'm trying to find out limit of f of x when x is approaching 2 versus limit f of x when x is approaching 1, it has two different behaviors. When x is approaching 2, I put 2 squared by 2 minus 1, so 4 by 1, it becomes 4. In this case, it became undefined. So this function definition gets split into two parts, where you will say f of x equals x cube plus x squared divided by x squared minus 1 when x is not equal to 1, because this is when the maximum problem happens, and this will be equal to, I think that's where I will stop. I will not go further here. X is not equal to 1, and I will say x is also not equal to minus 1 as well. Because if I am looking at minus 1, this part, this 0 thing comes into the picture, and that makes it undefined again. So let's look at few examples that will clear some dust for us. Okay? So I have put different flavors of it. Right now the only narrative that I want to start with is, if I have a function definition and if I have to find out the limits for any value of x approaching any value of x, we can get the value of the limit of the function by direct substitution, but there are certain caveats that we need to be aware of, and you will see all the flavors of those caveats when we go through these problems one by one. Okay? Shall we start? Yeah? So what we'll do is, we'll not try solving each and every problem, because I have put around 20 problems here, and if we try solving all of those, we'll end up taking 3 classes. So our focus is going to be primarily on making sure that we understand it very clearly. So this one, the first question says, find out limit of x approaching minus 5, h of x for h of x being equal to 5x plus 4 divided by x plus 8. We have to find out h of x for x approaching minus 5, and this is the definition of h of x, which is 5x plus 4 divided by x plus 8. What will you do? Simply substitute x into this one, like what Vedansi did, the first question. Okay? And see what happens. When you put minus 5 in place of x, this became minus 25 plus 4 became minus 21 divided by minus 5 plus 8. So this became 3. Minus 21 by 3. Yeah. So that is nothing but minus 7. That's it. This is direct substitution example. Okay. So we don't want to scratch our head too much for this one. Yeah. And we'll see a lot of application of conjugates also. Whatever you would have learned in complex number concept, we'll see application of that also. Now, Chris, Ananya, Vedansi, are you guys okay with what we did? I mean, I was just giving you guys a jump start, that's all. Let's go to the next problem. And this time we will not try solving it, you guys will just give me a story so that we can move to the next one. This one says, find out limit of x approaching minus 1, 5 minus 11x. How much it is? Or what will you do? Whenever you guys come across this problem, it should not take you more than 30 seconds in the actual exam. Even without using calculator.
Plus or minus 4.
Plus or minus 4? Yeah.
Yeah.
Yeah? Chris, agree with that? So here, now after having talked about limits for this long, couple of classes, still when you come across any problem like this, your first attempt would be, let me substitute the value that the limit is asking for and see what is that I am getting. You should just like plugging in, it's like evaluating a function, okay, for this value of x, whatever it's approaching towards. Just by plugging it in, whatever value you get, if you get a legitimate value and that doesn't give you any confusion, you are good to go with that. Okay? Let's look at the next problem. Next problem is find out limit of x approaching minus 1, 6x squared plus 5x minus 1. What are you guys getting? Chris, what are you doing towards? How much? Negative 5. How about Chris?
Yeah, negative 5.
And you guys are trying to find out s limit x approaching minus 1, right? It's not a limit 5, that's what I was thinking in my mind. Simple thing is substitution. 6x squared plus 5. I'm sorry, Vina?
I thought it was an extra bracket beside x. That's why. I thought it was x squared, not 6x squared.
Oh, okay. There's a bracket here, then there's a 6. So you guys are blessed to have a nice handwriting that your teacher has. Okay. So 6 minus 1 square plus 5 into minus 1 minus 1. This is 6, this is minus 5, this is minus 1. So the limit here is 0. And 0 is still defined. If I am getting a value of x equal to 0, it's defined. Our problem is when I am dealing with this. This is when it's undefined. Okay? So this was the easy one. Now let's come to an interesting problem which is extension of what we have done so far, and this will be our first opportunity to explore our knowledge. This one says find limit of x approaching 3 x minus 5 square divided by x minus 3 square. And the options that you have are minus 2 over 3, 0, 11 over 3, and there is the fourth option which says limit does not exist. Now, what will be your option that you would go with? You have to find out limit of the function or limit of x minus 5 square by x minus 3 whole square where x is approaching 3. I would not give you guys more than 20 seconds for this problem.
It
Does not exist. Because you're trying to determine for x approaching minus x approaching 3. As soon as you put 3, you have a 0 in the denominator. Straight away give up. Vedansi, do you agree? Ananya?
Yes.
Okay, let's move on. So I'm just trying to give you guys a flavor, a feel of the kind of problem that you guys will come across, and how do we solve them with minimum time and maximum conviction. We are trying to find out limit of this function where x is approaching minus 5 and it is described as x minus 3 times x plus 4 divided by x plus 5. 10-second problem.
It doesn't exist.
Does not exist. Chris and Vedansi, do you guys agree? Simple. You are only focusing on the denominator. Now comes an interesting one. Now it will make you guys aware of what you have learned while dealing with trigonometric functions or trigonometric identities. It is asking us to find out limit of x approaching pi over 2 where for function sec of x. And the options you have are minus 1, 0, 1 and does not exist. There is no denominator here, okay? Still it's giving us one option, D, which says does not exist. Let's see. How do you guys recall your expertise with trigonometric identities or trig ratios? I would say this is also a 30 seconds question or maybe 20-second question.
I'm just fine. So there's not.
I'm sorry with that?
It's undefined.
And this is undefined. Okay, let's see what this says. Okay. Okay, now who will explain this to the teacher who doesn't know why it is so? Grace, do you want to give it a try?
X is 1 over cosine and cosine pi over 2 is 0, so we need to divide by 0.
Yeah. So I was just trying to make sure that you guys are able to quickly recall this thing. These things will be part of your life. Okay? I mean, this table that I keep talking about. I mean, you guys will have access to calculator at any given time in any exam. But remember this. These angles are most commonly used angles, and if we remember this, the value of the table for all of the most commonly used angles, this will help you. Even that 2 seconds extra that you will take for taking a calculator out, you can save that also. You should remember this. Yeah. How much is sin 45? Let's see who remembers it. Sin 45. How much? Square root 2 over 2. Yeah, 1 over 2. Yeah, that's right. Okay, fine. That was just a random check. Okay, now let's go to the next one. Here comes a splitwise function. Now we have a function definition like this. G of x equals x by 3 minus 2 for x less than 6 and greater than 0, and this is cos of x times pi for x is greater than equal to 6 and less than equal to 10. Okay, find g of x limit x approaching 6, and the options you have are -1, 0, 1 and d as in does not exist. So if you guys are having difficulty in reading this question here, let me make it a little bit bolder. The function definition is like this: g of x equals x by 3 minus 2 for any value of x when x is less than 6 and greater than 0. And the second part of the function is, it's saying it is cos of pi times x for x is less than equal to 10, greater than equal to 6. So between 0 to 6, this is the definition of the function. For 0 to less than 6, and here for 6 to 10 less than equal to, meaning when x is ranging between 6 and 10, where 6 and 10 both are included, this is the definition of the function. You have to find out limit of g of x when x is approaching 6. This time I will give you guys 45 seconds. Let's see how you guys are wrapping your head around this one. Everybody can see the question, right? Vidansi, Chris, Nandya, you guys can see the question?
What is the number before pi?
X. So let me write a cleaner version of it. X by 3 minus 2, and this is cos of pi times x. Okay? Enjoy it for next 45 seconds. Maximum. What is that? Say one more time. 1. Okay, option 3. I will give. Remaining.
It doesn't exist.
Does not exist. I'm loving it. I enjoy you guys fighting with each other. Let's see what Chris says.
I can't search for a cosine pi exactly.
I'm sorry, that?
Like for the second piecewise portion, like what is it saying? Like cosine
Cosine of pi times x.
pi times x.
Yes.
Yeah, I think it's 1.
So there are two options that prevails here. Now I am having the video power right now. Let's see which one is right. It is asking us to find out x equals when x is approaching 6, when g of x, you have to find out g of x for the limit x approaching 6. Now here we have two flavors. One is when x is approaching from negative side, or when x is less than 6, and the other flavor is when x is coming from the positive side.
Wait, I take it back. I think it's not.
Now you are thinking. Okay, so again, I have not concluded yet. I am not sure which one is right. So let me try finding it out. G of x when x is greater than 6, x is approaching 6. If I think of this scenario, when x is approaching, so whatever it is, when x is approaching 6, when I am looking at this side of the story and this side of the story, when I am looking at this side, when x is less than 6, in that case it will be 6 by 3, 2 minus 2, 0. Okay. So in this case, what is happening is it is somewhere here. Okay? And then when x is between 6 and 10, 6 included, this is cos of pi times x. X is 6 here. We are trying to find out for x approaching 6. So this is cos 6 pi. 6 pi. 6 pi, if you go back to unit circle, 6 pi meaning 2 pi, 4 pi, 6 pi. So you are coming to this one, which is equal to cos of 0 degree. Cos 0 degree is nothing but 1. So here, this guy is, when x is 6, you have a value and you have things approaching 1. So there is certainly a break here. Yeah. Now Ananya and Chris are saying that limit does not exist, and that is how we will treat it, because we see that when x is approaching 6 from this side, it's landing here, and x is approaching 6 from positive side, it's landing here. There is certainly a break. They are not approaching the same value. Yeah. So now what is happening? We are looking at direct substitution as well as the limit concept together. Yeah. So now remember this. If anybody talks about calculus, they will talk about two things: differentiation and integration. And you guys might be feeling that okay, we have not started talking about differentiation and integration yet, because these are your building blocks. If we get this 100% right, that is when differentiation, integration and all the rules that we learn as part of it will become a cakewalk for us. So this, we are right now building our foundation, okay? It's like when you see a house getting constructed, when they are doing the foundation, you don't get a sense of what kind of house you are getting into. But if the foundation is strong, you will love the house and the stability of the house as well. Let's move on. I keep preaching you guys in between, okay? Just to keep you guys motivated, okay? Let's go to the next problem. And this might give you a different flavor. So let's see. Now we have to find out limit of x cube minus 9x divided by x squared minus 3x when x is approaching 3. I would want you guys to do all possible thoughtful evaluation of this one before you arrive at a solution for this. I'll probably give you guys little more than a minute, maybe 1.5, to think about it and create your story that you want to explain to me and the class. Everybody can see the question, right? Vidasi, Chris, Ananya? Yeah? Okay. Thing 6. Okay. I will come back to hear your story now. Let's see what Ananya and Chris get.
I asked for that
Chris comes to.
Yeah, I have 6.
Okay, can somebody explain me? Okay, let's go to Vedansi. So Vedansi, tell us why do you think it's 6? And we'll see if any of your friend is wanting to counter that understanding.
At first, I simplified the x cubed minus 9x to x in the bracket x squared minus 9 divided by x times x minus 3. Then I further simplified the numerator as x times x plus 3 times x minus 3. And then I removed the x minus 3 from the numerator and denominator. And I further simplified it by removing the x's, which would result in the equation x plus 3 as the function. And since the limit is supposed to be approaching 3,
Right. Now you guys will have to hear my story. So calculation part I agree. I agree to the answer also. Chris and Ananya, you guys also thought the same way, correct? Now look at how our innocent brains process this kind of problem. We started the class with the idea of finding the limits with direct substitution. So our first attempt was, let's plug in the value of x equal to 3 and find out the value of this. As soon as we did that, this became 3 cubed minus 9 into 3 by 3 square minus 3 into 3. And we straight away landed in a situation where it became 27 minus 27 0 by 9 minus 9 0 and defined. Yeah? That was our starting point. The direct substitution did not help. Correct? Yeah? Chris, Ananya? Yeah? So now, direct substitution did not help. So, we are going to the next step. We are trying to find out, we are getting undefined, that means if this function is graphing something like this, when x is 3, there is a break. That is what it is leading to. Okay, let's look at what we can do to simplify this. This here you found x being common, this became x square minus 9 divided by here x common, that became x minus 3. Here this x square minus 3 square. So you said okay fine. This is x times x square minus 3 square, that becomes x plus 3 times x minus 3 divided by x into x minus 3. And you knocked off these two. And now you see that okay, this guy is the culprit for x approaching 3. So we are saying that okay, when x is 3, that is when it becomes undefined, so there is a break, there is a discontinuity here. But for calculation purposes, you say okay, we are just taking it out, we know what this guy has to do. And this is my simplified form of the function. I will try to plug in the value of x equal to 3 and see what it gets me. So 3 into 3 plus 3 is 6. So 3 into 6 divided by 3. So 3 and 3 gets knocked off, 6. 6 is my answer. So from this simple looking function, there are two concepts that we explored. One is we can find out the limits by direct substitution, but not every time it will work for us just by substitution, because there is a condition in this definition of the function where it becomes undefined for this one, and that aligns with our understanding of the limit concept. That okay, for that value of x, it becomes undefined. That's okay. There is a bit of discontinuity, but otherwise it approaches the same point from both the sides. Yeah. So if you ask me, did I add value? No. I just recreated your story with a different way. That's all. Yeah. Whatever your brain thought or processed, I just talked on your behalf. Now let's look at some more interesting problems. This time we are going to deal with finding out limit for x plus 1 divided by square root x plus 5 minus 2 when x is approaching minus 1. How much this would be? We have to find out limit of this function x plus 1 divided by square root x plus 5 minus 2 when x is approaching minus 1. What will happen in this case? And the only clue I can give you guys is this is related to the concept of conjugate that we have learned in complex numbers. Somewhat similar to that. You can leverage that concept for simplifying it.
Is it 4?
You got 4. I don't know whether that is correct or not. I will come to that. Let's see what everybody else gets, and then we'll kind of revalidate that. You got 0. Okay, let's see what Chris gets. So we have two options so far. 4 and 0. I'm sorry with that. Okay. So now we have 3 kids, 3 options. So 4, 0 and does not exist. Let me go to Ananya. Why you think that it's 4? How did you come to 4?
I mean, when you plug it in, you get 0 out of 0. So then I like looked at the denominator and I multiplied it so by itself. So like the square root of x plus 5 minus 2. And then just multiply it by itself and on top and bottom. And then by simplifying it, you get 4.
Okay. Let's see what why Vedansi got 0.
I think I remember wrong. So instead of just multiplying the denominator by the square root of x plus 5, I also multiplied it instead of x plus 5 square root plus 2 so that it will take away the denominator in all things.
Mm-hmm.
And then I multiplied it up above, right?
Mm-hmm.
And then when you plug it, you get negative 1 plus 1 to be 0. And since it's all multiplied by it, so anything, the numerator becomes 0.
Mm.
And then the numerator is 0, anything divided by 0 divided by anything is still 0. So,
Okay, so yeah. I mean again, I heard Rania and I heard Vedansi both, and I'm okay with the way you were thinking about it. I'll do the calculation part just to make sure that we are clear on that one. But there's one dirty technique or rule that I very strongly believe in is our problem is mostly with the denominator. Any equation, any problem, any calculation that we are doing, we get maximum trouble because of the denominator. If I have 0 by something, we are okay. If you have something by 0, that is when the problem starts and we say this is undefined. So we certainly want to get rid of this problem that is created by the denominator. Okay, we'll always look at what do we do, be it dealing with complex number, be it dealing with any algebraic polynomials, be it dealing with any trig functions, ratios. Our maximum effort has to go for knocking off the denominator. That is where the maximum problem is. So here as I was giving the clue that it is somewhat similar to the conjugate. We will use the conjugate like concept here. This is my, let's say this is my real part, this is my imaginary part, or this is my imaginary part, this is my real part. What we'll do is we'll multiply this with the denominator with its conjugate. Like what Vedanta was talking about. Here I have a minus, I am multiplying that with a plus. So that this square minus this square kind of thing, and then the radical side we can get rid of. And then here we have x plus 5 plus 2. So we multiply with this, both the places. Now because of this, what happens is, this became x plus 1, x plus 5 plus 2, and this became this square minus this square. So this square is x plus 5 and minus 2 square is 4. So this became x plus 1 times x plus 5 square root plus 2 divided by x plus 5 minus 4, that is x plus 1. So we were trying to knock off the radical sign from the denominator and became a blessing in disguise. We can literally knock off these two. And this is what we are left with. Yeah? Are you guys with me so far? And again, before I did all this, we first tried substituting the value of x equal to minus 1 in this one. This is minus 1 plus 1, 0. Minus 1 plus 5 is plus 4. Square root of that will give me a 2. 2 minus 2 is 0. So 0 by 0. That's why we are doing all this circus and drama to simplify it. Because we have silently acknowledged that when I say approaching minus 1 for this function, it is becoming undefined, 0 by 0. Undefined. So we are just trying to see what is the limit that we are leading towards. And by doing all that, we found this. Now we are trying to plug in the value of x equal to minus 1 in this one and see what happens. This became minus 1 plus 5 plus 2. So this became 2. This became 4. Square root of that will give me a 2. And then I have a 2 here, which will make it 4. Yeah? So I think Ananya, you gave 4 as an answer, correct?
Yeah.
Yeah. Vedansi, this one will be actually 4 based on my calculation unless I have messed up something. And Chris. So here, look at this whole storyline from beginning. This one, we first tried substituting x equal to minus 1 and we found this became 0 by 0. And we find for x equal to minus 1. Now we are trying to see how we can simplify this and figure out who is the culprit who is making this whole thing become undefined. And that is, we are just trying to knock off the denominator. So we multiplied this guy with the conjugate or plus sign in between. That made this square minus this square. And we have to multiply the same thing above also. Square root x plus 5 plus 2 below and above we have multiplied. This guy became this square minus 2 square, that is 4. This square is x plus 5 minus 4. And here, whatever we had, we kept it. We did not do any distributive property here. But after doing all this calculation, this became x plus 1 times this divided by x plus 1. So when you look at this thing, this one thing common in numerator and denominator after doing this one, that clearly tells us that okay, under these circumstances when x plus 1 is equal to 0, we will have 0 in the denominator and that makes the function undefined. That means x equal to minus 1 is when the function becomes undefined, otherwise behaves properly. Okay? So this function starts misbehaving when x equal to minus 1. Or it becomes discontinued at that point. But when you knock it off, then your function is this, square root x plus 5 plus 2. When you put x equal to minus 1, this became 4, square root of that is 2 plus 2. Now, Vedansi is not completely wrong. Okay? Vedansi is thinking about, see, when I am doing square root 4, I will get plus 2 and minus 2 both. When I am getting plus 2, when I am taking plus 2 as an answer, my answer is 4. When I am taking minus 2 as an option, minus 2 plus 2 is 0. So that is how there are two values of this function that exists. Okay? I will be completely wrong if I say square root of 9 is equal to 3. No, we have two options here, plus and minus 3. We cannot discount that. So if Vedansi got 0, that means he was considering the minus 2 option, not the 2 option of square root 4. Am I sounding okay or not really? Vedansi doesn't seem to be convinced. Neither does Chris.
No, I understand.
Yeah.
No,
Okay. How about Vedansi? Are you convinced, Veda?
Yeah, I made an algebraic mistake. That's why I got it.
No, so see, making mistakes is perfectly okay. You guys are taking it way too seriously. I was just pulling a leg. Okay? No, I was just saying that, see, your answer of 0 is not wrong either. Because when I am doing a square root of 4, from this I am getting square root of 4 plus 2. Square root of 4 is not always 2. It could be plus 2 or it could be minus 2 both. So when I am considering minus 2 as a square root of 4, then my value is 0. When I am considering plus 2 as a square root of 4, my answer is 4. So both the options exist. Depending on what are the options you have to choose from, you can decide on that. Okay, so now we have come to the top of the hour. We'll probably wrap up here, but everybody has access to the questions I have put, to the WhatsApp group, right? So what you can do is you will find some more questions, okay? Starting from last two questions, okay, which is more on the trig ratios, trig functions. Try solving those offline and let me know if these are making sense or not, okay? If you are able to solve it by yourself. One is limit of x approaching pi over 2 for cot square x by 1 minus sin x, and the second one is limit of tan square theta times 1 minus sin theta when theta is approaching pi over 2. So these two questions you can attempt offline and let me know if you are able to do it. But the underlying concept will remain the same. First you will plug in the value to see what you are getting. If you are straight away getting the answer, there is a limit, meaning function is continuous there. If you are getting it undefined, that means there is something that you have to knock out. There is something that is making it undefined. So find out that factor, remove that factor, acknowledge that yes, this becomes undefined at this point, but I am knocking off the common factor which is making it undefined, and after doing that, this is my answer. Yeah? This is a two-step process. Does it sound okay? Vedansi, Ananya, Chris, everybody okay?
Yeah.
Alright. So this is what we did for today. So let me tell you guys what would be our plan for next week. So we talked about limits, determining limits using algebraic properties. We talked about determining limits using algebraic manipulations. Next class we will pick up selecting procedures for determining limits. Interestingly, this first unit is the most comprehensive one. Okay, there are so many things to be covered because it's probably laying the foundation for us. Okay, so maybe 2 more classes is what we would need for getting rid of the first chapter or first unit. Then differentiation would start. Okay, define the basics of definition and basic derivative rules, and all that we are doing is a preparation towards that. So bear with me for 2 classes or 3 classes. Let me see how many units, how many sections we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, we have 10 more chapters in this unit before we can say this is done. So 10 chapters we will probably try covering in 3 classes. We will try going a little bit faster with some practice without compromising on it. Today probably we took a little longer to solve more problems. We can probably focus on the key areas that we want to practice, and then I will leave for you guys to practice it more offline. We will try covering this in next 2 or 3 classes, not 2 classes. And then we'll start our journey with differentiation. Yeah? Alright, with that being said, I'll let you guys go. Enjoy your the evening part of the weekend. And make sure that you are always practicing your concepts of trigonometry, logarithm, and basic algebra, because that will keep coming back to you as we learn and practice calculus more. Okay? Alright, have fun. Bye bye. Bye bye.